Hey, hi all. Good morning and good evening. So today we'll be covering the data wrangling with Python. So it's a beginner's introduction to it. And the main, so a little bit introduction about ourselves. So we are support vectors. So we are specialized in training on AI and machine learning courses. And apart from that, we also take some consultancy projects. But today this meetup session is about how do we handle the data, because data can come in different forms, right, and different types. And Python inherently has some ways to handle it, but those are not that efficient. So we'll see about those things. And uh, yeah, so first I think I would advise you to all log in to this portal, because all the sessions will be posted here and will be uploaded here under the tabs here later. And the Zoom link is also available here. And better to join the Discord server invitation if there is any links that you want to share or any kind of communication that has to happen. So that can take place there very easily. And yeah, for today's session, yeah, the code is, you can see it here, or this data engine. So if you just click on it, it will download the code for you. And so you will see a tar file that you can unzip. And inside this tar file, you will see a folder called data engine. And it has a relevant code that we'll be covering today, and the notebooks. So I hope everybody has downloaded or logged in at least. Yeah. So once you have downloaded the code, yeah, so you can open the data wrangling folder. Yeah, for that, I think let's go to the project guide first, or I'll just show you what the course entails. Because there are a few things that I should take you through before. Yeah, so for I think I'm expecting that most of you are familiar with the is Python, at least a basic understanding of Python language or any other language, so that the concepts become more clear here is what these libraries, NumPy, Panda, and this data wrangling does. And for that in Python, I think you might have used Conda and for environment creation. And there's another way of UV. I think some people might have used UV also. So we are using UV here for the environment. So I'll just activate so my environment is already created. So I'll just activate it. And npdocs is for the documentation. So from this folder that once you extract that folder, right? After that, we'll have to do UV sync. And after UV sync, we can run this command npdocs.serve, and it will, sorry, and it will start a server and my documentation that in the project has. So that will be visible here. So in your cases, it will be in the local host. So I'll come to that later. So that command is already present here. But let me just go through a little bit of curriculum. So it will have mainly 4 parts, 4 days, right? So initially we'll just start off with setting the environment and Python. So some of you might be using VS Code or Cursor or any other environment. So we are using VS Code here for the development ID and UV for the environment. Okay. So first day we'll go through the basics of NumPy and Pandas. So NumPy is mainly numerical Python for the numerical mathematical operations. They become faster and more memory efficient than compared to normal Python lists or Python constructs. And Panda stands for panel data, so mainly for CSVs or other kind of documents. So those can be easily loaded even from data from SQL, that can be easily loaded into a data frame. So we'll cover these 2 things in detail, and how to read those data, and how to access that, and how to then change any format there. Yeah, so in the second session, we'll see about assembling and manipulating. How do you assemble data from different sources, and then how do you manipulate it based on your requirement? Because if you are training a model or something, or you will need data in some specified format to be labeled or unlabeled. But for that data to make some proper sense to the model, you'll have to format it, clean it, assemble it from multiple sources, because it can come from either of the sources, public, private, or internal data. So we'll see about the assembling and manipulating part, and then tidying, cleaning, and if there are any values missing in the data, like some address is missing, some person's age is missing, so it will be like not a number or not applicable. So how do we handle those things? Whether we keep those columns, rows, or how do we handle that? So that kind of and treatment. And then there are some advanced tactics in an ML preparation. So this is the last. So today we'll be covering mainly the basics of NumPy and Pandas. And yeah, so I think, yeah. So first thing is if you go to project guide here, you'll see some introduction and a basic setup. So those of you, yeah, for UV setup instruction, yeah. So for those of you who are Mac or Linux, so this command will directly install your UV into your environment. And once that is installed, that is sufficient. You may also need to update path, but I think it may automatically do it. Yes, and so these are the instructions that you can follow to create the environment. And then once the project is there, so here I've already loaded the project. So, but if you have to load a project, so what you do in VS Code is you directly open a folder and just navigate to that folder. So I have this data wrangling. So you will also have this data wrangling folder. Okay, that the tar file that I have shared. Once you extract it, and you have to open this folder directly here. And once that is done, so you will not have .vnv because this is a UV environment that I've created after doing UV sync. So, but you can, so you'll have all these other items here. So I'll just give you an overview of how the structure here is. So it's PyProject.toml. So this actually contains the libraries that we'll be using here in this project, in this entire project, all the libraries which are being used, and the name of project and version informations that can be given here, and Python version. And then we have this npdocs YAML. So you see I did some npdocs, right? And this documentation came up here. So these are the markdown files. So once you do npdocs serve, so these files will can be seen in a browser in a nice format. Yeah, and there's a database here that will need because in Pandas we'll be loading some data from SQL tables to see how it works. And there's a config YAML. So if there's any configurations that you want, that you can save here in the YAML file as the key value pairs. Yeah, and I think you will have this .env example in your folder. You will not have .env. So what you can do is you can either change the name here. So this is the root directory folder of the path, like data wrangling. The folder that you have opened, the one that contains where you will do the UV sync, which contains the PyProject.toml. So that will essentially be the root folder. So we need to update this thing and Python path. So if there is any files in the source, so this is our source folder here, src. So this path of this, if you just copy this path, and this path you'll have to update here in this place. So this I have. So I'll show you my .env, which has it updated. Yeah, so if you see this bootcamp directory, so this is my root folder of the code, and this is the src folder that is present inside my root folder. So these two things we have to update so that it knows where our code is in this environment. So this was a basic overview. And source, if there are any source files, so right now I think it will not have much. If they have only hello. So most of the code, so I've shared is here. It will be in these notebooks. So I've shared with you 1, 2, 3, and 4. So we'll be going through mostly 1, 2, and 3 today. And the remaining I'll share with you as we go on, proceed to the next day, next sessions. And one lab, I think this will be a homework lab. Yeah, so VS Code, I hope you might have downloaded it already. Yeah, so VS Code, I think most likely most of people will have, or something cursor or something you will have, and they'll be comfortable with it. If you don't have, just download it. And then UV, we definitely need it. So for Windows, this is a command here, So this part, for now, you will not be able to see it at mpdoc because you don't have UV. So in that case, you have the code and you have opened the code, right? So if you go to docs and the project guide lab notes, yeah, you have the project guide, right? You can just open it and you will have everything here also. So this is for Windows and this command is for Mac and Linux. Yeah, once that is done, then yeah, about this third part, environment, yeah, UV sync, I'll tell you about this part. So yeah, I think I'm done with this. So I'll just kill it. I don't need it as of now. Yes. So this is my root folder, right? The one that I'm showing you here in the VS Code. This is the remote server that I'm using, a Linux box and sets. So the code is here. So you can see this is the code and it contains all these things. So PyBlue is here, right? So one thing is what we have to do is all of you need to do is after you have installed UV, so you just have to do UV sync, and UV sync will. In my case, everything is already, the environment is already created, right? So it is just resolving it whether everything is fine or not. But in your case, if you'll download all the dependencies that are present in the PyProject toml, right? This, yeah. So all these dependencies it will download and it will create a folder named .vnv. So this is your environment, which will be using to run all the code that is present here in the notebooks. Okay. So this part you need to do. You can do it from here also, or if you want comfortable with Python here itself, you can just go to terminal and do it from here also. Yeah, terminal, and then it's for the comfort. Yeah. So other thing is once this environment is UV environment is created, right? Then we have the notebooks here in docs notebooks. So we'll go to the first notebook here, introduction to NumPy. Those all others. That we're not distracted. So yeah. So in this, yeah, if you see the Jupyter notebook, for those people who want to do it, so you need to select an environment here, using which this notebook will run, the kernel. So for that, you can just click here, and I can do a select on the kernel. Yeah. So for the people who have not selected yet, right, it will be showing select kernel. So just click on that select kernel, and you will get this Python environments, and then click on Python environments, and you will see .vnv, .vnv bin Python with a star. If you're opening the folder, data folder, rightly, so you will see it this way, and you just have to select this, and your environment will get selected. Now you can run, you're good to go. You can run the notebook easily. So only two steps. One thing is UV sync to create this environment, and other thing is selecting this environment in the notebook so that this can be used here. Okay. So now I'll just start the first lesson here, which is the introduction to NumPy. So yeah. So as I explained earlier, right? So in case of Python, the numerical computations, so they're not memory efficient or not that fast, or I would say in case of vectorized or matrix multiplications, they are not very intuitive also. So we'll see how that is. So why exactly is it? So one thing is the list structures aren't quite up to the task for heavy numerical computations, and is they're great for normal coding, but in case of machine learning or training a model, your data sets are too huge. So in that case, those calculations will take a lot of time there. So for general purpose, they are fine, but they lack the speed and efficiency which is required for crunching large data sets. So it is a long back in 2005, and it's short for numerical Python. Right. So the main component of NumPy is like ND array, n-dimensional array. So it could be one to any n-dimensional array. So in that case, right, so the performance in case of matrix multiplication or multi-dimensional array manipulation or multiplication or any kind of operations that we want to perform on those multi-dimensional array. So they give very remarkable performance because it uses Fortran libraries, because Python uses some interpreter, the code itself, Python code itself. But in this case, they're calling the Fortran libraries of BLAS and LAPACK, so which have evolved a lot. over time. And there's one more thing called SIMD, like single instruction multiple data. Like they use some parallel processing. Like if we have a list of items, two lists with 10 items, if you want to sum those. So instead of doing it one by one, what they do actually is they will take all the 10 items and single operation like addition you have to perform. So it will perform at the same time on all 10 instead of going one by one. So that is the main advantage. And it goes to Fortran libraries. That again speeds up the thing. So you will see a lot of people using NumPy and Pandas in data science or AML field, because, and then you'll go to Tensor, but that will come to later. Yes. So the main thing is like the basic operations like vector addition. If you have two vectors, addition, multiplication, anything that you want to perform on those vectors, and matrices. Because if you think of the later artificial intelligence model training, so matrix multiplication is essentially the thing that happens there. That's the main crux of it. And vectors. So it's all about vectors there. So it's like for any kind of mathematical operation, if you're thinking in Python, you want to do some heavy mathematical computations. So the suggestion would be to go with NumPy first. Because, and we'll see why. We'll see the performance and the intuitiveness that it provides. So for this, to explain that, so we'll just take one example which will show the strength of this NumPy array over the normal list that we have in Python and the calculations. So we are taking one rectangular plot for now, only one. So its area, as you all know, is length by width. So length of rectangle and width of the rectangle. And other thing is, if let's say is parameters. So we write it as this way, right? Parameter equals 2 times length plus width. So now let us see, let's calculate it for one initially using the Python code. So it's a simple code. We are just using the same formula and calculating the area. So it will just print out, right? Now let me just run the code also along with going. So first we need to start here so that it will load some common libraries and environment variables for that part. And yeah, then so this part I explained. Yeah, so we'll see here. So this is the area. Now, if you, so for one, this is how you will do, right? But suppose you have a list of 10 plots or 5 plots. We are taking 5 in this case. Then, and if, so you can make one array of length, one array of width, right? So if you see 5 is the length of first plot, 3 is the length of first plot, then second plot, third plot, fourth plot, fifth plot. So for 5 plots, this is how we have. Now suppose I have to calculate the area here for all the plots. So means my normal intuitive expectation would be that I get an array 5 into 3, 15, something like that, right? And for all 5 plots. And that will be easier to look at also and intuitive also. But in order to do this part, right, how would you do this thing? Is calculate the area for this list. So you can use one way will be to use list comprehension. You can try to change this later, or even now if you're comfortable, and see how else would you do it. So length and width, we will just iterate over this length and width one item, xy, and then we are doing the multiplication and we'll just print the area. So the area will be like this. I have not done this. Yeah. So we are getting it properly, right? As we are expecting. But yeah, thing is, this is how we are doing it right now, and how efficient it is, that we will see the time part and convenience part. So now, but instead of this, if we could have written it, if it was possible to write it as length into width directly, and we get an array. If you run this part, right? I'll just comment it. So this seems more intuitive, right? If I directly do it, but it will just can't multiply sequence of non type of list. So it cannot do multiplication here. But we'll see the same thing will be possible with NumPy, and we'll see how intuitive it is. So likewise, for parameter, I think this is self-explanatory. Yeah, if you do it in Pythonic way, so what will happen? So it will just append these two. So if you see 2 times of length plus width, so it has taken the length 1, 2, 3, 4, 5 here, and then this is the width 3, 2, 5, 7, 8, and then it is repeating 2 times. So instead of doing what we are expecting, it is doing something else, right? So this is not what is expected or even correct, but this is the way Python will handle it. Yeah, now for numerical analysis, now let us see how the NumPy will handle the same situation and what we have to do to use it. Now let us see the same thing. So the same array that we had earlier, right? Length of 5 plots and width of 5 plots, the list. So this is the library NumPy. So we'll need to import this. And then we are just taking NumPy length, NumPy width. So we are converting it into NumPy array, the length, the Python array into NumPy array. Now we'll see. So now with this area, if you see, you can NP length into NP width. We can directly multiply these two arrays here. And for perimeter, if you see, again, the same thing that we were trying to do for Python, but it was not working properly, right? So we'll see, yeah, we'll run this now and see. Yeah. So you just 2 lines, everything is done. And we would normally write lines into brackets, the formulas, the intuitive way. So this is the one advantage here that we can see. Okay, and here thing is element by element is happening, but it is like a vectorized computation. Like everything happens in one go, not like sequence to sequence, which I explained earlier. So when the data set is large, then we'll see how much time difference is there. So this part is the intuitiveness, nativeness, how to write it, the writing comfort wise, right? Intuitiveness wise. But let us see the execution time. How much time difference will happen if we use both of the approaches, right? The NumPy way and the normal Python way. So for that, this is the code. So this compute area, if you see, so it has length and width, and this is the normal compute area. So we are using the same thing here that we had done earlier, right? Compute using Python list. And the other thing is NP compute area. So here again, we are getting length, but this is NP array here. So we can directly do this length into width, right? Because it will be. And to measure the execution times, what we are doing, we are passing this function. Later we'll call them this function with the arguments and keyword arguments, measure execution time. So we are just checking the start time, and here is the end time and the result. So whichever function is passed to it along with the arguments, that function will be executed, whether compute area or NP compute area, based on what we are passing to this measure execution time. So now so for this, what we need length and width, list and array, right? So let's take, so initially we are taking this length. So yeah, for this length, yeah, so we are taking in the range of 1 million, because if you see time here, it will be very fast, right? Execution. So we're taking a million size so that we can show significant difference in this execution time. Otherwise, it will become too small. Yeah, so what we are doing is, so randomly we are selecting numbers between 0 to 100 for the length in this range. So we'll have 1 million items in length and 1 million items in width. So totally 1 million plots we have. And for them, we are calculating the area first. So yeah, this method. So this method is what we'll call to measure it, and we will pass a function. And it will return the execution time, how much time it took, and what is the area. So if you see here, execution time and area. So these two things we are getting out of this. And in the first case, it is compute area directly the list. And in the second case, if you see, this is NP compute area, NumPy compute area, and it will convert it to an NP array first. Okay, so we'll just run it and then see the execution time. Already there, but yeah. So if you see, for the same items, we see the first one, the Python way, it is doing in 0.02, and it is doing in 0.001. So at least more than 10 times faster. Because it is 1 and this is 2, so like you can see order of 10 times at least. NumPy is faster. Yeah. So the main difference in this NumPy arrays and Python lists. So the main thing is ND array. That's what it means. When you think of NumPy, you should remember that n-dimensional array object is what you should remember. So which can store elements of same type. That is also one thing here. These are different types. If they can be like, if you see date, time, or true, false, like Boolean. So Boolean, that true false is there. So it can be essentially converted into 0 or 1, right? So it is not essentially numeric, but it can mix up with numerics. But we'll see that later. But usually it will have same type. So unlike Python list, we can hold, Python list can hold different type of data objects with a string or everything, and then they have to worry about resizing. But in case of ND arrays, they are fixed size. Once they're created, their size is fixed. What can be done is you can reassign them to a different variable, then it will get copied. So that can be done. But once they're created, their size is fixed and type is also fixed. So because of which they are much faster. They know the contiguous memory and how everything has to be done. Yeah, so now we'll see few common usages of NumPy, means how would you prefer to use it. So one thing is called NumPy subsetting. So here, if you see, the area is what we had calculated here, right? Execution time, anyways, we have compared here. So other thing is area. So we have area for 1 million items here. So this is a list. This is, let's see. Yeah. So if you have to access any of the items, like this is here, I'm doing A1. So this is the endpoint. So any item if you want to access, you can just access with the, I can do 0. Let's see what's the first item. So 4836, you can just print out them. And in case if you want to compare, like you have the NumPy whole list, right, of 1 million items. So you want to see which ones are greater than, which areas are greater than 30. So if you do it this way, see, it will return an array with true or false status. So if you see this, it has 1 million items for all of them. 2 to 2, some items are missing. This dot 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 means it can't show everything, right? 1 million. Yeah, so few will be false, few will be true. And now we can check how many also, because here if you see it's 1 million. But if you just pass this condition inside this here index as an index, so what it will do is it will check which ones are true, and based on that it will return only those items which are true, which hold, for which this condition holds true. So this is our NumPy array. If we just run it, we'll see how many items are there. So 969419, this is items. So this is one way to access it. Yeah, for non-homogeneous, I was just telling about that, the non-homogeneous part. So in case of non-homogeneous, so in case of NP array, if you convert it, so this is a normal list, Python list. So it contains true, false, true, false. So true, false, these are also manageable, because what will happen, 2 will be taken as 1, if you do a sum here, in that case, list 1 plus list 2. So it will be taken as 1, false will be taken as 0, and based on that, it will return the sum. So this is one thing. And if you see the type also, so in this case, it has Boolean and int, so the type will remain int only. So this is how it promotes hierarchy. So if you see bool, int, float, complex, and then object, this is our hierarchy of the types in Python. So based on that, it will means whichever, if any element is of complex type, then it will become complex. If all others are less than it, so based on that, whichever is the higher in hierarchy will become the type. So we'll see that here. So in this case, right? So I'm taking just list 1, same thing. I have just put one string here, A. So in this case, if I check the type of here, it is showing num.string. So same way, if I just change it to true, now this 3.1 is there, right? So string and object are similar. Yeah, so it will become float. This is higher. But this is ideal, means usually people do not approach things this way, but sometimes you may have a situation where these things are present. The non-homogeneous arrays. Yeah. So till now we saw the 1D part, right? Single array, one-dimensional array. Now let's see the two-dimensional arrays. So how things, so we'll take the same example that we covered, right? The plot one, the length and width. So but instead of, so here if you see there are two lists. So we have taken a variable plot dimensions. So these are plot dimensions in 2. So this is 1 cross 5, this is 1 cross 5, right? So it has 5 columns if you see, and 2 rows. So 2 cross 5. That is its dimension. So now we are just converting it into an NP array, NumPy array. And after that, we can just print the dimensions and see what is the shape. So if you just print it out, so that's how it will be presented here in case of NP array. And this is like a matrix, like an array of arrays of matrix, and its shape. So matrix will have a shape, right? So this is 2 is a row, 2 rows, and 5 is the number of columns. So number of items is 5 and 2. So and plot dimensions dot shape will give you that. What is the dimension of your matrix? So let's run this. Yeah. Now you have NP array and in like 2-dimensional matrix. Now how would you access them, right? So in case of Python, if you have a 2-dimensional array, so if you see, this is the way usually that you will do the row within the square brackets, and then square brackets you will do column. You have to select zeroth row and all columns. That's how you will do. But in NumPy way, it's a bit different. So if you have to access any elements, right? So you will just give that and put plot dimensions, and this is the row here. 0 is a row, and comma. You have to use comma here, row and column. So in case of column, if you put column, I think those who are familiar with Python will understand this this colon thing. It means all, from 0 to end, all the, it means all. And 0 means the 0th row. So what we are trying to print here, the first dimension, the row, 0th row, and all the columns of that row. So if you see here, this is the 0th row, right? 5, 2, 7, 9, 8. This is the 0th row, and all the elements. So if you make it here, I'll just to show you, I'll just so if I just make it 0 to 1, let's see what should be the output here. Because it will be inclusive, 0 to 1, only one item. Because 1 will not be inclusive, the end part is not inclusive. That you should remember. So same way you can print, if you want to print 2 items, 0 and 1, or if I want to print 1 and 2, like 2 and 7, but only 2. I have to make it 3 minus 1, 2. Yeah. So that's how you can access a sub part of the element. Okay. Yeah. So now in this case, if you want to calculate area now, because you have a 2-dimensional array, right? So the area will be like 5, 3, 2, 2, 7, 5. That's how you have to do, right? But instead of that, you can directly access this as plot dimension 0th row, and this is the first row. Yeah, and if you provide only 1, in this case, it will be row only, the first dimension only, because column you are not giving, so it'll take the first all columns. So if you take the 0th one, so it will print. So we can see it. So we are just multiplying these two, just the NumPy way. Yeah. So this is a few ways of how would you organize data and how would you access data and the array. And just remembering it. The main thing to remember here is like row and column is row, comma, column. That's one thing. And then I think the main things are similar to the Python way. So few statistics in case of NumPy, like if you want to get generating any data or anything. So this is for the generation of data through NumPy. So NumPy has this function np.random.normal. So I told you, for mathematical numerical computation, mathematical operations, like no matter how complex it is, so NumPy would come handy. So like here, if you see, so I think you might all be aware of the bell curve, the Gaussian distribution of the bell curve thing, right? So it has a centered mean and around which the data is distributed or located with a standard deviation of sigma. So this function, so np dot randomly on normal distribution. So, and this is a mu, sigma, and n. So mu sigma is a mean, this is a standard deviation, and n is a number of samples that you want to generate using these two, mean and standard deviation. How many samples you want, n will be the number of samples. So if you see here, this is what we are doing. So earlier we used something else for generating it, range. We use range, the Python. Now we are using the NumPy way. In this case, so if you see here, normal distribution, so what this will do, so it will take the mean of 40, 30, and it will generate 5,000 samples. So in this way, up to 5,000. So these numbers will be random, and the same thing the other will do. And the NP round, we are just rounding the decimal points. So after this, what will length have? Length will have 5,000 random items, right? So length variable will have that. Width variable will again have the same 5,000 items, but with a different distribution here. Yeah. So now you have two columns like this way, right? Like two rows, like had earlier. Now, if you want to stack these two rows in a column way, like if you want 1, 3, 1, 3 as one, if you see it here, right? The output here, column stack. What is the output? So what it is doing? The length 35, 23, 45. This is the 5,000 lengths, and 10, 12, 11, 9. These are the 5,000 columns. So earlier we had it this way, only a single list, single. Now what we are doing here now, if you want to stack them together for the, because it will become handy later. We should come to that. So it provides that facility. Just np.column stack the length part and the width part. So it will just stack them together in a two-dimensional NumPy array. So 3510. So I'll just run it. You can see less. Yeah. So now you can just see the shape of it. So what is the shape ideally? If you see, just look at this, right? So it has 5,000 samples and length and breadth, only 2 columns. So the shape will be 5,000 by 2. If you change the number here, then shape will change based on the number of rows. The column will remain 2 only because length and width only 2 are there. Yeah. Yes, and statistics, right? So in mathematics, if you have to calculate few, statistics like mean, median, coefficient, correlation. So those calculations also become very easy because it provides the functions for that, this library. So now if you see here, so I'll just, so all are doing the same thing. They are taking, if you see, all the rows. First one is row, second is column. So all the rows and 0th column, right, means the length. So we are taking along the length all the elements, like 5,000 lengths. So in case of mean, if you remember, mean will be like average only. Okay, so you need all the items, right, from 1 to 5,000. So that's what we are doing. So the mean of length, if we have to calculate, that's what is happening here. 45, 39, 46. All these are being passed because row is 0 here. This is a 0. This is also row 0. This is row 1, row 2. So we are taking all the rows, right? And column is 0. So for column 0, this part. So I'll just execute it. You can. Okay. Yeah. And then there's some NumPy array. Yeah. NumPy array mathematics, like the board mass operations that we do. So vectors, for them, addition, subtraction, multiplication, divide, square root. So all these operations, you can see how they will be performed here, like the basic arithmetic operation. You see. Yeah, 1, 2, 3, 4. Yeah, so if you see here, it is again 2 cross 2. It has one row, and this is the second row, right? And it has 2 columns, so it is of 2 cross 2. So this is also 2 cross 2, 2-dimensional. The matrix dimensions are 2 cross 2. So now if you have to perform any operations, so here, so it's as simple as that. And we dot add x and y. So what it will do, it will add each element to this corresponding element. So like the 1 will be added to 5, 2 will be added to 6. So if you see this 6, 8, this is some part. Similarly, subtraction, multiplication, in the same way it will happen here. And divide and square root, NP square root. So 1 square, 2 square. It is a single thing here, right? But in case of 2, how it will happen? So I'll just execute it, and yeah, and this is a D type. So you can also specify the data type here. So it has multiple types, int, float. So here we are taking it as float. Sometimes it may be a good idea if you want to fix what is the data type. But otherwise it will auto select something, which is the highest of all the elements. Yeah, so that was a normal multiplication, like the word mass that we do with numbers, right? Just that it here it will be corresponding elements, to corresponding element in case of NP array. Yeah, so if other thing is the inner product of you want dot product, right? So in that case we can use rightly. So for that also the functions are provided here. We don't have to write our own fancy code to do all those kind of things. It's already there. So x dot y, np dot y, so np dot, yeah. So the syntax is a bit different here. X dot y, and this, there's 2 ways of doing it. X, y. X and y will get multiplied. Easy dot. And this is the matrix multiplication. This is also similar in this case. I'll just run. Yeah. Now we have the x, right? This is the x. This is the x, and we are 1, 2, 3, 4. This is, so let us see how we can access our. So in the x, so you see x, if you have to compute all the sum of all the items, so you just do directly np dot sum allowed, and it will just sum all the elements. So it has 1, 2, 3, 4, right? So it will sum all the elements 1, 2, 3, 4. Sum, it will come out to 10. But if you want to sum along any axis, like if you want the sum of all the rows or sum of all the columns, right? In that case, x is equal to 0. X is equal to 0 will compute. It will compute a sum of each column x along axis. So if you see here, right, x is equal to 0 means row. So each column, so yeah, like if I'll just show you here just what it means. X is equal to 0 means it will take the x is equal to 0 and sum everything. So 4, 3 it will sum. X is equal to 1 will be different. The other way around, 4 and 6. We'll just see in x, we had 1, 2, 3, 4, right? Yeah, so 1, yeah, x is 0. So 1, then 3 became 4. So I'll just run it. And if you want to transpose, like if you want to switch the rows and column, because in few cases you will want that, because if you do a matrix multiplication, right? So it has some rule, right? 1 cross with m cross n, then the other one should be n cross k, or something like that. They should be a common factor between the matrix multiplication, right? So for that, sometimes you may want to transpose the matrix that you have, so that the multiplication becomes easier. So for that, if you see 1, 2, 3, 4, the rows and columns will get switched. You just have to do x dot t, and it will just calculate a transpose of matrix. So 1, 3, it will become 1, 3, 2, 4. Which I will get. Rows and columns will get switched. Yeah, now a little bit. Yeah, now a little bit of matplot we'll see, means a histogram. So usually visualization is also an important aspect here. So if you can visualize your data, you will understand, right, how it is distributed, or if there's any drift, because from this perspective, and if you think from the perspective of training your model for testing or training, so the training data set, sometimes a data drift kind of thing happens, like the training data is different, but the production data is a little bit different. So the distributions are different. So for that, yeah, there's one more course, yeah, data visualization. So they will cover that in deep, but here we are just showing a little bit of things. So histogram. So histogram is essentially a bar style, like bar chart, you can say, bar plot. So which will visualize a single numeric variable. Is how this one variable, if you take the length has a few values, right? So how that is distributed. So if you remember what we had done, like here also what we are doing, we are taking a normal distribution, right? It will be like a bell curve, right? The data has to be distributed like a bell, the Gaussian distribution. So that we'll see in the hist also. We can see the same things. So we are taking the mu and sigma 3 and 0.5, these are values, and again, same thing, the normal distribution we are calculating, and this time we are generating 10,000 number of samples. So this variable, this is a numerical variable that is changing, right? And it has 10,000 samples that we have taken. Now we can draw them out. So we can directly draw them out using the plot. This matplot library has histograms. So we just need to provide a variable and how many bins, how many partitions we have to do. Like if the range of the data is from 0 to 100, then how many bins means how many partitions you want. Like if you want to do 10 partitions, it will take 0 to 10, 10 to 20, 20 to 30, 30 like that. So we have taken 100 partitions here. So along the whole range of the values that D can have, right, from the minimum to maximum, so we will have the small, we'll have in between those, we'll have 100 bins, 100 bars that you see. So these are like 100 bars here. So this is like hist, so it will draw this kind of bar chart. And the other way is in NumPy also, you can do it here. You can directly pass it, and it internally uses this NumPy only. But the other way is if you want to use this NumPy way, so you can just use np.histogram. This also has the calculations for it. So you have to pass the same D bins equal to 100, and there are a few other parameters which I will skip for simplicity. So you will do in the n bins, and then based on that, you have to plot these things. right? So, and in this case, we are plotting only, not a histogram, so it will be a line plot, but they will be similar. Same, the bell curve you see here. Island. Yeah, a few examples. One more example of this chart, right? We'll just see how we can generate all the values and then chart. So if you have to take again same any variable if you have to take, so we are taking multiple values. So in this case, you can call NP arrange. So this will just take the start value, stop value, and what is the step you want to take. So in this case, we are taking values from 0 to 3 pi, np.pi. This is the pi. Pi is 3.14 approximately. So if you take 9 dot something, so it will be like 0 to 9 point something, right? We'll have, and the step we are taking is 0.1. So if you see here, this is the x variable. So if you see here, x variable. So it is ranging from 0 to 8, and then this is something close to 9 point something. And this is y-axis. So the value of sine and cosine both, they vary in the range of -1 to 1, right? So for this range, now we can just create a function y sine, y cos, y sine, sine x. So if you see this y sine, this will contain all the values of sine for all the values of x, like a line space, like this curve that we have drawn here. And based on that, you can just simply plot them out, just to visualize. This is a simple one, but you can do more complex. Yeah. So that is it from the NumPy way. Next, we'll be covering the pandas. So if anybody has any questions here, or I'll take questions later also. We will also take questions later also. But if you have any doubt anywhere, yeah, please feel free to stop me or interrupt me. So I'll close it. So yeah, and please try to run the code, because if you run the code, means you'll get more comfortable with the environment and other things. Just going through it is okay, but once you do it, then you understand the syntax parts also, how a little thing can create bigger issues. Yeah, so NumPy was for the numerical Python only, right? Mainly for mathematical operations. And Panda is for panel data. Panel data is like mostly if you see the Excels you have. So in Excels you have different columns and indexes, right? Rows 0, 1, 2, 3, 4, maybe from 0 or maybe from 1. Then the multiple rows. So on left side we have the indexes. On the top side we have the columns A, B, C, D, and sometimes we rename the columns to whatever we want. And similarly, if you see a table structure also has the columns, right? And the entries. So if you have, yeah, so for that kind of panel data, pandas is very helpful. So it also uses NumPy in a few places for numerical calculations, but we'll see about that. But the main thing of pandas, what you have to learn is, right? Means you should to load data from multiple places like CSV file, Excel, you see SQL databases, those kind of preferably. And after that, once you have loaded that data, right? After that, then you have to clean it, analyze it. If you want to do some analytics on that, what is the average age, what is the average height of all the people, what is the average salary, or what is the highest salary, so those kind of things, the analysis that you want to do. So that also you can do it very easily here. And then the last part is visualization. So that also can be done with this, but for visualization, we'll have a different, more elaborate session. But you can do it here. So we'll see that part here in panel. So let me just introduce a bit here. So NumPy, as you know, it is fantastic for numerical computation. But what if our data is not just numbers, right? Because we'll not always have numbers. We'll have names, states, categories. Like categories, if you say like gender, male or female, right? So it is not number. It is not an item. It is just a category. It can be only of these two things. Dates, you understand dates. Names like a string. String can contain a lot of things. So NumPy, it is okay with the arrays or numbers, right? But with heterogeneous data like this, because each column has a different type of data here, right? Because in case of NumPy, if you take in an Excel, so usually the two rows, one will have name, the other will have the age. So let's say if it is age, then it will be number, name will be string. These are two different types, right? So now handling that with NumPy is not possible. But with this, we'll see how it handles that scenario also, like a spreadsheet or Excel, if you read do anything there. Let's just like do it in Excel. You'll see how it can be done in code, and once formatting is done, it can be used for later processings. Yeah, so pandas, as the name says, it is like panel data, and we'll see. Let's see, and it is also a library just like NumPy. So I'll just run from the start. See the execution also. Yeah, so we need to, this book install, you don't have to do it because our Py project Toml is taking care of that. Once you do UV sync, all the libraries which are needed for this project will get done. But specifically, pip install, or in our case, we are using UV, so we will be doing UV add. If you have to do any installation. So in case of Conda, we use pip, right? But in case of UV, we have to do UV add library name, and it will download it, install it, and along with that, it will also update it in your Py project Toml. The pandas, it will take care of that. Yeah, so I'll just import it first, then we can see how it is. Yeah, so in data frame, so if you think of Excel data, right, or CSV data, so it is arranged in column ways, right, like name, age, qualification, etc. And so if we can think of it as a columnar data, right, instead of thinking of it as a row-wise data, because if you think of rows, so each row will have, suppose each row will have 3 items, and but is the name, age, but they will be of different data types, right? But if you take a column, let's say name, so data type of that column will be same, right? It will be string only. And if you take the next column, maybe date or age will have integer, or if you want to do it in float, the same way date will have date only. So if one column can be thought of as one unit, right? One list. So that's what here it is. So columnar data storage. So one of the key concepts in pandas in columnar data storage is this stage. A will be of one type, B will be of one type. So this is the way they handle it generally. So, but in case of NumPy, we know they will be homogeneous. Here it will be different. And here it uses data frames. They are two-dimensional. It is also two-dimensional. But in case of NumPy, we can have n-dimensional, not just 2. We just covered till 2 because it is easy to visualize till 2, right? If you go beyond 3, also it is okay. But beyond 3, it becomes difficult to visualize the axis and the dimensions. But yeah, but with data frame, it will always have 2 only. So we'll say C with the access spreadsheet. So what I explained, right? A, B, C, D, these will be the names of your column. And 1, 2, 3, 4, these are the row indexes. So this is the index. So this is how the terminology is. If we come below here, so this is called row, that we all know. And each row is identified by its index. It has to have some index, 1, 2, 3, 4. So I can identify it or access it using anything like panda or something. Then 4, 3, 2, 1, whichever I want, or 1 to 4. We'll see that later. So this is called index, but the term we use for it is index. And for columns, the term we use is column label. So it will have a column label. So whether it is of name, age, etc. The label of the column. Yeah. So in pandas, if you sorry, to think of, right? So there are 2 main components here. One thing is series. So and other thing is data frame. So if you see this whole Excel, this column Excel, just have a look at this, the vertical axis. So if you see A, B, C, D, E, all this, right? So if you see, take only B, right? So this has what item from 1 to 11, let's say in this case. So it is like an array, right? Like a series, like of one type. So this is called, in pandas, this will be called a series. If I take one column, this will be called series. And if I take multiple columns, that becomes a data frame. Like so a data frame essentially is a collection of, or dictionary of series. So we'll have a dictionary A, all the, so A we'll say as a key, and the values will be the list of all the items here. Then we'll say comma, B is the second series, and all the array items, all the list items here. The same way C. So like collection of series, right? Dictionary of series can be thought of as panda data frame. So these are 2 main items that you should keep in mind when someone asks you pandas. And this main part. After that, it's similar to Python, not something that you should have in mind if pandas thought comes. Yeah. So the other thing is Yeah, so we'll just see how we can do all the operations that we mentioned earlier: loading, inspecting. So first thing is, so this is for loading data set. So we are loading the data set from here. So I'll just go to this. We'll just have a look at one of this. So this is weather data. So what is how the weather. Yeah. So this is present here. This is our SupportVectors. Yeah. So this is yeah, we have a data hub here. So here, if you see, it has column station, date, tmax, tmin, the temperature. This is a station name, I think, and yeah, station name. And this is the date 2010 0101. Format is like this, and this is temperature. I think this is in Kelvins, -178, -311. So this is a temperature, max temperature and min temperature at that station. So now this data, if you want to load in this is a CSV file, you see, right? So now if you have to load this data into our data frame, and like if you want to do any kind of analysis on this or any cleaning, like this date format is not proper, right? If you see, it is just number. So if you can format it properly, like 2010-01-01, it becomes easier. So right now it's data type will also be not date time, something else. Temperature is fine, but if you want to change it to degrees or Celsius or something else, right, then we can do that also. But that we will not see here because that is a mathematical calculation only. Right, and the same way here, if you see station, if you want to break it down, so we'll see. First part is loading this, right? We have this data in the CSV. Now, how do we load this data? So for that, it provides very easy functions, and you just call the functions. So if you see data frame, so we'll have let me run the, did I run the code? Let me run the code. I didn't, yeah, I ran the code. Yeah, so pandas as PD we have installed, imported, right? Pandas pd.read CSV. So just do this, it will just read CSV and replace star with the, and this, yeah, pd.read star. So it will have a lot of other methods also, just apart from read CSV, other file type. So it will check it and just replace the CSV with that file, but we'll have to verify that it exists. Okay, sense. And the source path, we can just directly give the URL or the file path. In this case, we are giving URL, or if you want, you can also give the file path also to your machine. So let's see what to do. Now it has executed fine. That means this file has been loaded now into data frame. Okay, so remember data frame series. Data frame is a collection of series, like a dictionary of series. This is data frame. Now let's inspect it. So what it has, this data frame. Has it got everything fine? So one thing is shape. So shape, remember, so it is a two-dimensional thingy. So it will have, so how many rows? It has 31 rows, and columns are 4. So we saw it here, right? Columns are 4 only, 1, 2, 3, 4, 31. I don't want to count it, but it is 31. So that's why 31 items, 31 rows, and 4 columns. So data frame has 31 rows and 4 columns. Now, if once so you have loaded it, now you have to make sense of it to view it. So in order to view it, right, for the generally dataset, this is a small dataset, so you can view the whole thing here easily. But suppose it had 1,000 items, then you would not want to view all the 1,000 items here, right? Because you can't, it will be difficult. So you can just inspect your items. Means out of 5,000, if you just take the first 5 or last 5, you can see, right? Okay, first 5 is fine, last 5 is fine, my count is fine. Means everything is loaded up. Or you can do a count also, but you want to inspect whether it is loaded or not. Mainly for inspection, we use this everything. So df.head. So head means that it will take the top 5 elements. So 0, 1, 2, 3, 4, indexing from 0. Which we just run it. So it will just print out the first 5. Tail the last elements, the last 5 elements. So you can see 30. So it is indexing starting from 0. So 31 items. Yeah. So you can see all this. The top, initial and last we can see, but if you have to make a conclusion out of only this, we can just, yeah, station name seems to be same, right? But we don't know about the between 4 to 25, right? Whether it is also same. Yeah, but I think it's most likely same, but that's a different way. But that we can check anyways by checking the unique count, other things. Yeah. So these are the items. Now let us see what we can do with it. So first thing is, this is the data. Now what are its types, right? And type conversions. First, we'll see what is the type of each of these columns here. So if you just print the df.d types, so we'll just see all the types. If you see station is a string, so it takes it as an object here because for some reason. And date, if you see, it is taking as int64, right? But if you have to do some operations here, like some date operation, date comparison, so it is better if you can convert it into a date time. Then that thing becomes easier. So this is one thing we should do. Another thing is station. So this is an object right now, but the thing is, the way we see it, it looks like it is a string. So we can, instead of using a higher class, right, we can just use string, so that the handling will become much easier. Like, because in case of object, if you say it is an object, then there will be a lot of redirections to find out that it is string and then do some operations on that. So it is recommended that if you see any object type now, and if you know that it is a string, so better change it to string. So we'll do these things. So first we'll convert this station to string, and we'll change this date format from int64 to date time. So these two things we'll see how do we do this type conversion here. So first is getting to know what is the type. So overall it's an object, that's fine. But for date time, there is one lab later to go into detail in date times. But for now, so you can see the format. So in Pandas, there's a function to date time directly. So it will convert into date time. And we have to just provide which format it is present in right now. So right now, if you see, it is present in YMD, right? %Y. So it will understand 4 elements, %temp, 2 elements, day, anyway, this is the last, it can be anything. So this is the format that currently it is in, YMD, right? Year 2000, if you take last item, 2010, 0131. So this is what we are passing, the format. And df date, which means which column we want to change, right? So what it will do is it will change all the items, if you see. And this is how you assign it. So you're taking df.date. So date is in this data frame. If you see date is one series. So if you access date, right, so you can just access date by using df and this date name, the label name, the column label name, and then you just do pd.pandas.to date time and this date. And if you execute it, you will see the format has changed properly. Now you can see also, okay, date is proper. You understand it makes sense by just looking at it instead of deciphering it. Readability is also better. And if you see the type would have changed. And the other thing is, so this is changed. The other thing I was talking about, we'll change the string from object to string. That's the same thing here again, df station. So what we are doing is only as type string. Whatever type you want to convert it into, convert it, and it will get converted. And now if we just print out, we'll see both the types have changed. So it is a string, it is date time. So this is just to tell you how to convert type of any column if you want to change. Because sometimes what happens, the numbers are also taken as a string or string. So those kind of conversions you might have to do sometimes. And so this is the type thing. Now let's see what we can see. Like we have loaded a huge data set, let's say. Now for that huge data set, we want to see means how it is distributed, like each column, what is the statistics for that, whichever can be calculated. So if we see, so this is the data frame that we had, right? We'll just describe it. So when we call describe it, so what it does is it will take all the like numerical or numerical like tmax is a numerical number, right? And date, if you see, it is a date time is a number, but essentially what happens is it's not a number. Date essentially what happens is internally it gets converted into nanoseconds, so it becomes into the integer number only. So that's why for these date, tmax and tmid, you see some count, mean, minimum value, what is the minimum value, what is the mean value, and what is the top means 25% range, what is the average of that, 50%. So these values is standard deviation. If applicable, it is not applicable here. In case of data, I think here is applicable, so it is showing it. And you can just view your data. But right now it is not showing string or anything about the string because the station is missing, right? We had a station column also, but it is not showing a station. So that is the reason, because by default it will take only numerical or numerical type. But if you want the description matrix for that also, station also, in that case we can add include all. So it will include everything, string, object, all types, and it will just try to produce something. If that metric makes sense for a string, it will have some value. If it doesn't make sense for that particular type, then it will be a not applicable or not a number. We'll see that. I'll just run this and it is. Yeah, so if you see here, this count, I think was, yeah, what has been added here is unique. Unique was not present earlier here. Count is there, but unique is not there. Unique top, if you can see, and you can see the other things are for station, the other things are NA, and they are not applicable. Only what is applicable is shown here. So this is just to describe if your data makes sense to you. It means ideally means that this is how my data is and was, and if anything has changed. But that is just the observation part. So we can just observe here what comes out. Now, another thing is changing the index. So we talked about two things, right? One was the column label, which will be the column headings, right? A, B, C, D in visualize Excel. And the rows, the index is the left side, the row numbers. So if you want to change any index, like initially index, it was, if you see here also, the index was like 0, 1, 2, 3, 4, number was 0 to 31, 0 to 30, the number was there, right? But if you want to change your index, because sometimes it is good if you can just put a date here and then just see all the records corresponding to that, right? Instead of seeing that number 1, 2, 3, 4, it makes it more clear in some cases. So if you want to do that, so in that case, you can just do a set index. So df.set index is date. So you can set any of the column as a index here. So in this case, because this makes more sense, if you arrange the data by date, it makes sense, which is station, what is the temperature, max and min. So that's what we are doing here, and we can just do it. But there's one catch here. It is done, but it is not actually done in the data frame. We'll see why. So it seems everything, it has, this index has changed because it is showing it here, right? But it has not happened in place. It is just giving the output. Now, because if you do a df add now, right? It is still same. Date is coming here, but we just changed it, right? But in memory, it has not changed. It is given a copy of it. So if you do it in memory, in the df that exists itself. So in that case, we have to make sure that we pass in place equals true. So remember this thing. Sometimes this mistake happens. People forget this part. And there's one more thing, a drop. We'll come to that drop. That also happens. You will forget to write this and you will think, why is it not happening? Why is it not happening? Unless you understand, means read everything and then, okay. But small mistake that can be ignored. So now if you see, after setting index this way and making it in place equals true, means it has to change the same data frame that is there. That's what we are saying essentially. And then we are printing out the head. So if you see it here, yeah, now it has changed properly. Now our data frame that was there, it has changed. And we can later, if you want, we can again make it into a column. We can drop the index here. We'll see that in the next. Yes, set index. Okay. And this is a little bit of exploratory data visualization. Actually, yeah, I was telling you, right? Yeah, next week there's a class. There's also free class. Next week, same way. Is for data visualization when class is there. So in that we'll see in more details how to visualize, because data science visualization helps actually. If not you, at least the people who don't have much time to look at everything, right? All the data, they'll want to see, okay, how data looks, so that I can get insights quickly. Yeah. So it also comes in handy. And it's a basic thing, so knowing it really helps, the database and all. Yeah, so matplot. So right now, so here we'll be just using the mat. So this data frame itself. So we talked about, right? We can plot here also, but eventually means usually if you'll use a matplotlib, because it is more advanced. In data frame, we'll see what we can do. So if you have this data frame, right, and the line plot part. So this is a data frame, and this is a tmax. This is one of the column, right? One of the series of the data frame. So we can just access it using the label name, the column label name, and then we are just plotting it out. So it will do a line plot of how this temperature is varying, right? You can say the x label equals date. So you can see this tmax, how it is varying. So this can be easily plotted here. So this is mainly a plot part. If you see it here, and yeah. So this is only single, right? For single, yeah, you can just pass it this way. But if you have to select more than one column, right? In that case, this should also be a list. Like if you see here, right? It should be a list here, this part, square brackets, notice it. Because in case of one, only one is fine. But in case of, if you have to select more columns out of the data frame, in that case, you have to pass it as a list, the items, all the column labels as a list. And now you can see that tmin and tmax both are plotted here. Interesting. Yeah, it is. Yeah, histograms. So earlier we saw, right, how the distribution. So there are two things. One is the frequency count can also be shown in the histogram, or we can show the density also. There are two things. But, so this, like if you want to draw histogram here, just like earlier we saw, right, with matplotlib and also with the, yeah, with matplotlib only, and NumPy way of calculating it. So it can also do it that. So it, for Tmax, it is calculating the densities here. And there are different types of plots actually. So that comes under visualization part, like kernel, there is one kernel density plot. So I was checking it. So it is a smooth, this case is a chart. It will be a smooth chart, which is also telling about the probability distribution, means how it is distributed, the variable. So you can just click on it, you can just see it, and I think you can read more on this, the visualization parts, what are each and everything. Yeah, and then data frame you have in memory, you have made all the changes, everything is done. But now if you want to save it, right, you can either save it as an Excel itself, but if you want to save it to a database, so that can also be done. So in your database, yeah. So in this case, we have this database here. It's here, and it's in two places, but I think this is the one being used. It's the one being used. Yeah. So yeah, for connecting to SQL, I think people might know, those who have used Python, SQLite C, you can directly use this SQLite DB. So it will just create a DB file. If it is not present, it will create it. Or if it is already there, then it will not. It will just connect to it. So let's connect to it and see. Yeah, so this is gen temperature. This is the name we are giving to SQL connection. We are just checking. Yeah, df to this data frame that we had, right, above. That's what we are putting under this table, gen temperature. Now we can see whether it is actually gone to the database or not. So we'll query it. We are now reading it from the gen temperature. So we'll see data frame read.read SQL. So earlier we were doing read CSV. Now we are doing a read SQL here. So we are loading data from SQL. I think, yeah, that is, yeah, so that is the end of pandas. So that's all we covered, right? Different terminologies, mainly that two things I was saying about series and data frame. One column, like a series, think of it as series. Multiple columns, like the whole thing, the data frame. Data frame, if you think of it as a collection of, or dictionary of, to be proper, dictionary of those items, columns and lists. The dictionary of series, essentially. And then how do we load it, and then how do we inspect and change things, indexing, and then how do we just push it and visualize. Simple visualization is here, but for the advanced visualization, yeah, that will be covered in the different session altogether, classes altogether, course, I mean to say, the next week course. But yeah, a little bit what it can do, data frame can do, that we have seen, and exporting the data. I hope the things are clear, at least NumPy and pandas. You got a basic idea, right? Basic understanding, high level, what it is, why it is being used. Yeah, if there's any question, doubts, yeah, you can ask, because people, with them, yeah, there's some support staff also. They can also help. So I'll cover the third one more today. Data assembly. Yeah, I can cover third and fourth. I'll see based on the time. Do you guys want some break, or I'll continue? 5 minutes, 10 minutes? I think we started at 1:30. It has been 1.5 hours, right? Okay, I think we don't have, yeah, we have only half an hour left, right? Yeah. So I'll better get on to it. I'll just cover that his third notebook today. And then there's a homework here that you guys can try at home. Miss, I have shared 1, 2, 3, 4, right? So till 3 I'll cover. And there's this lab, Giants lab. You can just look at it. It is not very difficult. A simple one. Yeah. So I was telling about those. No? For those people, select kernel from where it's coming. So it is a very small thing. Just data frame and pandas. Just try it. If you're not able to do it tomorrow or day after, we will share the solution also. But it's good if you can try. It's not a big thing. Yeah, select kernel. Select kernel. So I'm getting this environment name here directly, right? Selecting it. So I'm just repeating it for those people who are new to UV and VS Code. No? Otherwise, if people are comfortable, yeah. So this is so lab 01. So this you would have already. So I'll just close it. I'll close this also. Yeah. So NumPy is okay done most likely. We have NumPy, like what you have to done mainly is learn all the libraries that all the functions that can be used, like the mathematical function. If you need anything, just search over the one more thing I should do. I should show you guys the tutorial link. Like for NumPy, if you want to go in detail, right? I've covered it, but still in more details. So what is NumPy and all that installation? Installation is simple. UV add NumPy, right? But for beginners, it has here they will have some documentations. So you can if you want to go in more detail, right? Just going through it once is sufficient, and then using it. So this is for NumPy. It's a good resource from NumPy yourself, and the other link is for Panda. So these links are anyways present here also, means in the notebooks also. A few places you will see the links are there. And apart from that, if you go to this course build, right? So here there are a lot of links here. So like Zoom link, everything. And apart from that, I will upload the recordings also here. So NumPy, if you go to NumPy, you will see some resources here. Yeah, few reading materials, and you can just go through each of them, whichever you like. Some more reading materials after apart from the class. Yeah, so yeah. Yeah, so I'll start with this. How do you so data frame part, rows, index, columns, changing the index, that part we saw. Now we'll see what more we can do with all these rows and columns, because we have to select few columns, read few. Sometimes you have to delete things. Sometimes you have to rename few items, adding two data frames together. The adding, I think we'll see in the fourth. But yeah, but here we'll see how do you operate on this pandas data frame. Okay, let's go. Yeah. So here, if you see this one, right? So what I was saying is earlier, so data frame. So data frame, so intuitively, if you think of it always this, like one way is Excel. If you see Excel, yeah, that is one intuitive way. The second way, like the same Excel, if you have to convert into a JSON. So how will you do? You will take the first column name. This is the column name, right? This is the key, and these are items of that column. First column. This is the second column name, age, the second key in the dictionary, in Python dictionary. And then this is a list of all the items, like Jack corresponds to 27, Peter corresponds to 24, Gail to 22. And if you miss something, then it will take not applicable, not a number, something like that will come in the data. So same way, third column, fourth column. And if you just see this is essentially in Pandas, we will call a series, right? Series. Yeah. So this is our data right now. So it has 4 columns, 1, 2, 3, 4, yeah, and it has 4 columns also and 4 rows also. These are the columns and these are the row items, right? So we'll just let me start from beginning. Yeah, remember, if you are running it, remember to run this, because it imports some necessary stuff. In few cases, if you don't run this, yeah, you make. In few cases, not in all cases. Yeah. So yeah. So this data, now this data we can directly load into data frame, right? Because it is proper dictionary format. And this we can just see what it is. So now we have your name, age, height, qualification. So everything has appeared here. Now we have it in data frame. Now what we can do with it? First thing is, like in the previous one also, right? We need to describe everything. So it is small data. We don't essentially have to do it, but just try to include all, just like a reinforcement here, so that you remember it if you do it. Yeah. Then let's description. Now let's see how do we select a column. Yeah. So this part, yeah. Anyway, I think in last one I covered. We'll see in more detail here. So we had 4 columns. Yeah. So in data frame, this is a data frame, right? And name was the first column. So we just choose name, and it will just print out all the items of the name, whichever. If I want to change it here to age, it will give me age. So here it is name right now. So we'll just print out name. Yeah. If I want to change it here to, I should know the column name. Column name should be correct. And column name, what is the other column name, age, height. So the same way, if I just change it to HIGHT, it will give me the height and 12 prior types. Yeah. So actually, this is for the selecting any one single column, right? One column if you want to select. And if you want to select multiple columns, then also I remember now we had I think this was, yes, yeah, we'll come to it later. We'll have to pass more than one here, something like this you'll do. But we'll see it later, like these two. Like in case of single column, only just one part is sufficient, right? But in this case, you have to provide a list, height, age. So I've taken height, age, and in this sequence it will come. Okay. So I'll just remove it. Anyways, will come multiple, but I'm just showing. Yeah. And here, one more thing. This is like age filter. So if you want to, this is your data frame, data age. If you just do a conditional check here, right? Data age is less than 25. So all the people, so based on the age, I have printed height here. Based on the age, it will compare which one's age is less. So whichever holds true for that, it will convert that into true and others false. So you can see it false, false, true. So this can be used as a filter here. So now if I pass the data and then age filter inside it, so it will print out only those items which are true. Others will be removed. Yeah, will not be shown, I mean to say, for selecting. We'll see that later. I'm just giving you a heads up that what can be done. This conditional can be used inside this data instead of this height. You can use this conditional, and then you will get all the columns and the items here. So you can see it false because this condition is not being met here. Now for multiple columns, yeah, I just explained earlier, right? Yeah, this is accessing the columns. A list of all the column labels that you want to access. Just pass them. Yeah. Now the slicing part, I think people who are comfortable with Python, they will be very comfortable here also, because it is similar. So data frame, this was our data, right? So what in data.columns, so it will have all the columns. Data columns will contain all the columns which we have. So we have 4 columns here, right? 0, 1, 2, 3. We have 4 columns. So, but we are taking it, if you see 1 to 4, we are doing a slicing here. So the last one is always, remember, last one is excluded. Yeah, but in few cases I will come to later where it's a different thing. But here, if you see column, most of the places the last one will be excluded. Like it will go from 1 to 3, 1, 2, 3. So it has taken the first column, second column, third column, age, height, and qualification. If you see, right, age, height, and qualification. Yeah, age, height, and qualification. Because we have given 1, 2, 3, no? So 0, 1, 2, 3. It will take only these 3. You're slicing it. Yeah. And selecting subset. If you want to select a subset, yeah. So this is one way of selecting it, right? By passing the indexing here rows. The other ways is using a LOC. So there are 2 methods here in DF, right? One is LOC, one is ILOC. So ILOC is an integer location, means it is based on integer locations only, like 0, 1, 2 numbers you can give, like the slicing that we just saw. But in case of loc, what happens is we can access it based using the label names also. Like if you see it below here, right, in the data frame. So description, yeah, links I was saying that links are present here. So 1, 2, 3. So what it is doing, 0 it is ignoring, 1, 2, 3. So yeah, here this is what I was saying. In this case here, here it is inclusive. 1, 2, 3. So if here it's more like think of it as a labels. So index label. So in case of row 1, this is a label 1, 2, 3. It will take 1, 2, and 3. It will take, and here also it will take name and qualification. So we can pass 2 things here. and look. The first thing is the row, which rows we want. Okay, this is the first part, and this is the column part, right? Because we have in data frame we have row and column, two things, right? And remember we were earlier also in NumPy also it was similar while accessing two-dimensional array. Yeah, so name and qualification, these two we are printing, we are selecting. If you see, yeah, this is qualification and how it, and this slicing, this can be done anyways. Like here, if you see data log, it is doing 0 to 1. And yeah, other ways you can give it a list here. Okay, then only those columns will be selected which you have passed here, right? But other ways you can give a what do you say, range, like from first to second, from first to third. So this is one way. So first part is common, the slicing part. The second part is different here, right? So if you see from name to height, it is saying from name to height, just like it is saying from 0 to 1. It is saying name to height. So all the columns between name and height, right? Name, age, height, they will all get printed. If I write it here, the last column qualification, then qualification will also get printed. If I write from age to qualification, age, height, qualification will get printed. Yeah, same way. This column means taking all name to height, name, age, height. So it's yeah, remember the differentiate between these two, dot log and I log. People get confused. But I like for the int, if you remember, you will not get confused. That will take. Yeah, so here if you see again, it is most more about selecting it, how we are selecting it. Data.log1 means the 0, 1. So first item like Peter 1, right? This is the first index and all items. So 1 Peter 2466.2. This whole thing will get selected and it's going to get printed out. Now, yeah, one more thing is sometimes you may want to select column based on their types. Like suppose you want to investigate only the float types or integer types, right? Only those columns, but all rows. You want all rows, but you only want height because height is in 5.1, 5.2, 6.1. So it can be in decimal or let us say in this case, or weight, if it can be in. But so if you want only these two things, height and weight, and you know that these two are in float only, you have put them in your database, in your data frame or CSV in float format. So then what you can do is you can directly take all the rows, data.log, and what you can do here is set the data.d types to float and dot values. That only, so this will select the columns, right? So for whichever column this condition holds true, for those get the values. That's what it is doing. So if you see here, height, only height is in float, so that's only that one is coming here. If you want int, you could have done that. Yeah. So this is LOC, right? Now we'll see the ILOC. So so this is a purely integer. So remember with I means integer. So purely integer location based indexing by position only. Like here we were using this name, if you see here, right? Yeah, we had used this label names here, right? So instead of these label names, in the case of ilog, you'll only use integer indices like this, column indices. So if you see here, yeah. So Python also uses a similar way, but and NumPy also we saw this part, right? Row columns, how do you access? So that is it is similar to NumPy. Okay. So data dialog. So you can see. So it will take all the rows first thing, and column it has to take 0, 1, first two columns. Yeah, first two rows it has to take all, right? 1, 0, 1, 2, 3, all rows, and column it is taking 0 to 1. So this is again ilog, right? Integer base. So this will again, it will not be inclusive here because there it is more like a label that is being taken as label. So from starting label to end label there in LOC, but here it is like an integer. So in whenever you say that, generate a range from 0 to 100, so from 1 to 100, so it generates from 1 to 99, right? Leaving 1 or 100, like 0 to, so same way. So this is all and 0, 1. So name and age, only these two columns. So this is the index of it. This is the number, right? 0th column, first column, second column. Same I log, like if you have to row slicing, column also we are slicing 1 and 2. 1 and 2 will take and 0, 1. So 2 by 2 will come 0, 1 and 1, 2. Yeah, so this was about like accessing it. Now if you have to delete any column, so delete part is, I think, is very simple. you have to just call a drop method and pass the name of the column. We'll see this. So we are just retaking data because so that in case I want to start a code run from here, I can do it here. That's why we are taking it, and we have done some modification about on data. We're just again retaking it. So let's take it. So now we have data. This is populated. Yeah, simple as that. If you see, yeah, one more thing there. Yeah, and one more thing, if you remember, right, when you're doing multidimensional arrays, matrices, right? So in that case, they will have axis, right? So like first they will have rows, columns. If you take 2 cross 2, you'll have rows, columns. So axis 0 is row, axis 1 is column. Same way, if you have 3-dimensional, then axis 0, axis 1, axis 2, that's how it will go on, like axis n. But get comfortable with 0 and 1 first, 2-dimensional. So here, when we say axis 1, so what is axis 1 means column. We're talking about column. So here, if you see, this is height. So data dot drop height. Height we are dropping it. This height we are dropping from where? From the column. So it should be in the axis 1. This is axis 0, right? Row is axis 0, and this column is the axis 1. So this height we are deleting. If we had given axis 0, then it would have given some issue because height is not present in axis 0, right? That's why. So this is the dropping of the columns, axis 1. And so we'll see how, yeah, that is already present. Age qualification, then qualification is there, height, age is there, name is there, but height is gone because we have removed the height here. Now, if you want to just rename this column, suppose we say age, qualification, so name, age is fine. Qualification, we can change it to education. So we'll say, how do we change it? Just provide the old name and new name, data dot rename. That's it. Data dot rename, and the columns, you have to provide the old column name and the new column name. So from qualification, we are changing the column name to education. And one more thing here is in place equals true. Well, if you do in place, then in memory, in the same data frame, it will get changed. So in few other places, right, whenever you feel like you have done the thing, but you're not getting the output proper, like, so in that case, keep in mind that, okay, maybe in place or somewhere drop will come. In place, like in memory, do it in the same frame instead of doing it in a copy, because sometimes it will provide a copy if you assign it. Yeah. So if we just rename it, we'll see how it has renamed. So after renaming, we can just print out this data out column site, and it will just the name, age, education, and the whole data also if you want to see whether it has changed or not. So we have done column removal, and we have done this education qualification to education change. So both have happened. Deletion and renaming both have happened. Now if you have to add any column, so like adding any column, so we have name, age, education already. Now if you want to add one more column, add, right? Like in dictionary, which already contains a lot of series, I just need to add one more series to that. So in that, yeah, this part is really simple here. To add a column to pandas data frame, we can declare it as a new list. Simple. This address, we had 4 items, right? So we'll make sure the 4 items are there in this address list. Okay. Once we have the list, we just need to pass this list directly to this data frame. Data frame had already name, age, education were there, right? Address was not there. But if we just create it like this, df dot address, even though it is not there, we are creating it now, and this address we are passing it. That's it. The column is added to data frame. Now, if you see, this address is present here in the whole data frame. It has expanded. Yeah, so these are the columns. Now, if you there are some row operations also in the same things you can do along with the rows, right? Selecting, adding, deleting. So for selecting by same the LOC method that we had used for rows. Yeah, so first thing, yeah, we can do here is like if you select rows, right? So we'll be mainly selecting it by the index. Like column, we could have selected by data.columns, right? The column labels. Now for selecting this part, the rows. So for rows, we have the indices, like we had 0, 1, 2, 3, 4, those kind of, or we can have some labels. So it becomes easier if we just change one column and we change the index of this. Like, so here we can just like age we cannot, education, address will be difficult, but name is unique. We can just convert a name into a label. Let's set, sorry, not a label, index. Yeah, so we're setting the name column as an index here. In place 2 means the same place it has changed. And So that's what we're doing initially first. Then we'll see how do we access it. So accessing this column will be, this row will like accessing df Jack, df Peter, something like that. We'll see it later below. First we are just changing the index. Now it is like this. That's how the everything is. So based on label, we can access the rows. So we'll see here, yeah, data.loc. So using this method, just take Jack, take Peter, and just print out. So it will just take it. This is the row part, okay? Row. This is the index of the row now. Yeah, and then getting rows based on, yeah. Earlier I was telling about the age filter part, getting rows based on the condition. So here, if you select that here, getting to, this is called Boolean subsetting, means based on a condition, you want to get few rows and not all the rows. So if you just do data age, this is a data frame, right? And age greater than 26. So based on this condition, what it will return? It will return a, yeah. So these are indexes, right? Name, Jack, Peter, Gail, these are indexes, and it will return this array, true, false, false, true, that we saw earlier. Now I'll show you that the same age filter I can use here. This is what I did not show you earlier, this part. Like in select age, if I do data.loc and this pass this age filter directly here, right? This age filter. So what it will do, whichever are true will print it, and whichever are false will be ignored. So this is called Boolean subsetting. Here. So you'll see only Jack 27 and 32. Both are greater than 26. That's why they are being displayed here. Yeah. Now, if you want to do a reset index, like we had set name as an index, right? Now, if you want to do a reset, after everything is done, now let's say two positive integers, whichever number are there. Yeah. So here, yeah, I was talking about this thing, right? This drop equal to false is important here to retain the old index. If you want the old index, and drop equal to true means it will drop the old index and then means and create a new, reassign a new index column. Like instead of using the name, it would have created a new index. So that's why we are using to retain the old index, like 0, 1, 2, 3, come back to it. We'll see what it does. Drop true also. And in place is also required here. We'll see. Yeah, so it has now come back to its normal form. Now adding a row. If you want to, yeah, for adding a row, one thing is the concatenation. Right. So concatenation function, what it does is it takes a main argument of objects, a set of objects it will take, two objects, like two data frames you want to join, right? So those two key arguments. And one more thing is axis, along which axis you want to join, whether you want to join along row or column. So in this case, it will be row. In row, the axis will be 0. So we'll see. So new row, if you want to add one new row, okay. So it has a name, age, education, address, all the columns we are passing. These are the values they are passing. And pd.concat. So you see the new row is added first. To that, we are concatenating the old data frame. Okay. So this is the new data frame, new row that we have added, this data frame. And data is the existing one. And axis is 0. Axis 0 means along row. We have to add along row. So if you just print it out, I don't have it done. Yeah. So name, age, everything is done. Yeah. So this 0. Yeah. One thing you notice, 0 will work, right? So it has added it as 0 because it was means first item of the first one, right? New row. And we have added it at starting. So other indexes are like this. So now this numbering. So you would want it to be numbered from starting to end properly, right? So in that case, you can just reset the index here. So if you just do data 2 and just reset the index and drop equals true. So it will drop the old index, whatever it is, and create a new index from starting 0, 1, 2, 3, 4, and in place. So this numbering. So if you have multiple, so right now we have done only 1, 2, right? If you have multiple, then it will be like 0, 1, 2, 3, then again 0, 1, 2, 3. But if you want to count, so for that you can just do a reset index and drop equals true. Means it will drop this 0, 0, whatever value is. If you don't do is drop 2, then it will add one more index column. You can try it, play it around. Try to remove this drop equal to make it false, and then see what happens. It will add one more column here. Yeah, one more thing. So right now all the values we had provided, right? Suppose we don't provide some value in address or somewhere.
yeah, we'll see this one. If any value is missing, so it has age, name is there, age is there, qualification is there, but we do not see the address here. So in that case, what will happen, right? It will not say any thing. What it will do is it will just set that to NaN, yes, not a number. Yes, it is not applicable essentially, but it sets it to NaN in the final data frame that is concatenated. So again, we are doing the same thing here, concat array new with the old and x is equal to 0. And others also, you can see the qualification also. Adding and deleting a row. Yeah, so deleting again the same thing based on index. So what you can do is change the index to name, and then this data dot drop, same way, in place equals true. Yeah, so I think, yeah, we almost reached time also. Yeah, so this is input data from SQLite database. So this is a lab that as a homework, if you get time, you can try it. It is not much only related to data frame. And you can refer to the code here in 1 to 3. I have given 4th also. 1 to 3, you can refer to the code and see how we are accessing data frame, how we are loading it. Right, I'm from database table, what is table name. Yeah, so that is it from my side for today. So the next part will cover maybe 4, 5, 6. I've shared 4 only, 5 and 6 will share. The 4, 5, 6 I will cover tomorrow. So I'll share those notebooks also with you. And the recording for the today, I think, yeah, that will be uploaded to the course portal here, which you all should have access to. Code, anyways, you have it here. So tomorrow's code also will get uploaded here. And there's some reading materials here in this tab. So please see if you're interested in exploring more into it, right? Yeah. So NumPy and Pandas, I think these two you can go ahead and explore. These you can explore later as we proceed further. Yeah. So yeah, if you have any questions, anybody or anything, you can take it. But otherwise, for today, I am done. I hope it was interesting and meaningful. You learned something.